All right, guys, we're going to go ahead and take our circle notes today, and then whatever follows this is that worksheet that has the word homework at the top of it, and you guys can work on that as well. So we're going to start with the standard form of an equation, and that is written as x minus h quantity squared plus y minus k quantity squared equals r squared. Now, in an unshifted form, your h and your k would be 0, and this would look simply as x squared plus phi squared equals r squared, where h comma k is going to be our centered. So that's why when you have them as 0, 0, it's unshifted and is centered at the origin. And r is the radius. Now, r squared represents the square of the radius, but r itself is the radius. Now, this next word, locus is actually a formula that represents, it's basically a set of points that fits a rule. So I'm going to write those words down. A set of points that satisfies or fits a rule. Now, the rule that we're going to have here is that they're all going to be equidistant from, all points on a circle are equidistant from the center, which is a geometric rule. And that actually means that every xy that satisfies the x minus h squared plus y1 minus k squared equals r squared is on the circle. It's just a set of points that fits a rule. So we're going to identify the center and the radius of each of these circles, and we're going to graph it. Circles is actually one of the simplest ones to graph, because once you identify the center, which again we're going to do by using transformation, so this one would be 1 comma 2 because it was shifted to the right 1 and up 2. They are both opposites in this case. And then we have our radius is going to be the square root of 64, or 8. Now, the radius is a distance, and distance cannot be negative, but it can be in the negative direction. So we're going to have our center, which we will label with a C. And then, that's not our center. Our center is at 1, 2. So 1, 2, which we label with a C. And then we're going to move 8 in each direction. So we'll count 1, 2, 3, 4, 5, 6, 7, 8. And up 8 spaces as well. And to the right 8 spaces, or left, and then down 8 spaces. And we will connect this with the most circular shape you can draw, which means it shouldn't look like a football or a square, or a rhombus or something. So that's the best you can draw, then that's okay. And this is all we'd have to do. So let's go ahead and do the second one. First, we identify the radius of the circle. Since x has not been shifted at all, it's 0. And y, we're using the opposite, so it's down 5. So 0, negative 5. We will label that with a C. And then our radius is going to be 3. So in all 4 directions, we will go 3 spaces. 1, 2, 3. 1, 2, 3. And connect that with the most circular shape you can draw. It should not have points. It should look like a circle. All right, now moving forward, we're going to go ahead and write the equation of a circle given some information. So I say we're going to do those two things, be able to graph it and identify the information. We also could identify the domain and range for each of these, which maybe it's worth going back and trying for one of them. So we'll try on the smaller one here. If I wanted to know the domain of this, I'd be talking about what x values I would use, which in this case would be from -3 to +3. And the range of this one are my y values, which is at -8 up to -2. And remember, it is always going to be left to right and bottom to top. But go ahead, let's look at this in our radius. So if the center is -2, -7, when we write our equation, we use the opposites because of the shifts in the formula. And then I'd have y plus 7 squared. And the radius squared. So it's going to be 16 squared, which you can write as 16 squared, or you can write your 256. Okay, for this next one, if the center is at 0, 1, we know that the x did not change, but the y's did, and that would be the opposite, so we use subtraction. And then I'm going to have to square this. Now, we're not going to write this as 3 squared is 6 squared. We're actually going to square it because I want to know that you know how to do that. Okay, you're going to go into trig next year, and you're going to deal with radicals quite often. So 3 root 6 squared is 3 root 6 times 3 root 6, or 9 times 6, or 54. Now this time when I had the diameter, okay, in having the diameter, you want to definitely take half of that to get your radius, and then you also have to square it. So r squared in this case is going to be 144. So using the center of 5, negative 4, we write the circle equation using our shifts. And then on the other side, again, we took half of the diameter, which was 12, squared it, and got 144. For this one, again, if we're going to take half of this, technically that is half of it. And then when you go to square it, you're going to get 30 over 4, which would be 15 halves, or 7.5. So x plus 2 squared plus y minus 6 squared. And you may write 15 halves, or you can write 7.5. All right, and on to the bottom here. So again, given the center and the circumference. Now the circumference, we need to remember our circumference formula is 2 pi r. Or if you want to rewrite that, I think 2r pi. So you remember that what's in front of pi represents the diameter. And then the area formula is area equals pi r squared. And since our formula for the circle includes r squared, we actually just want that number. So going ahead and writing this, again, we can start with the center, and we know how to use those for our transformations. Y is unshifted. And then this right here, oops, let me go back to this one. This one right here is our 10. So if d equals 10, then r equals 5, and r squared equals 25. Okay, for this one, you want to use 4 root 6. If 4 root 6 equals the diameter, then 2 root 6 equals the radius, and squaring that is going to be 4 times 6, or 24. I'm going to go through that process again. 4 root 6 represents the diameter because it's the coefficient of pi. Then 2 root 6 is therefore the radius because that's half the length. And squaring that is 2 root 6 times 2 root 6, or 4 times 6, which is 24. So using our center of x minus 3 squared and y minus 4 squared equals 24. Okay, for the area, this literally represents your r squared. You don't have to do any work except making sure you got your shifts right. Done. 10 root 2 is r squared, so that's it. So I'm just going to go ahead and get my shifts right here for the center. And it is 10 root 2, and that's acceptable. Okay. So to finish this up here, for the next set of writing the equation, given a graph. So given a graph, I'm going to have to identify the center of that graph. And so that's my center, and that would be 1, 2, 3, 4, negative 4, negative 1. That's my center, and I know my radius is 1, 2, 3, 4, 5. And so writing that equation, just different information, right? So x plus 4 squared plus y plus 1 squared equals 25. Okay. Next one, before we finish this worksheet up here, my center is located at 1, 1, 2, 3, 4, 5, 6. So 1, negative 6. So if you want to start by writing that part first, x minus 1 squared plus y plus 6 squared, and then my radius we can see here is 2, so it equals 4. So these circles happen really fast. You have to be able to pull the information, but all you need is the radius and your center. So I'm going to give you 2 different formulas here. Our distance formula is actually the formula for a circle. So our distance formula is the distance, not diameter. Okay, distance, which is actually radius, because distance from the center. So it's actually radius. Maybe I'll write radius. Okay, so the radius is equal to the square root of x minus x1 plus y minus y1. And each of those is squared inside. Okay, so x minus x1 squared plus y minus y1 squared. Which, if you square that square root, you end up with a circle formula. with h and k being the point you're testing. Your midpoint formula is literally the average of your x's, so it's x1 plus x2 divided by 2, and y1 plus y2, the average of the y's, and this gives you the midpoint. And the midpoint's great if you know the endpoints of a diameter, because then you can find the middle, and the middle of that would therefore be the center of your circle. So if you have the center and you have a point on the circle, which is what number 11 and 12 offer, okay, that if I have that, then I need to know, obviously I can start by writing x plus 5 squared and y plus 6 squared. Like, great, I took care of that. But how long is the radius? And to do that, I'm going to go ahead and use this distance formula, or the radius formula. So that's going to be the square root of, and it doesn't matter which way you go as long as you subtract in the same direction, just being careful. So if I do negative 5 minus 2 squared plus negative 6 minus 3 squared, okay, that's going to clean up to be negative 7 squared and negative 9 squared. So that's going to be the square root of 49 plus 81. And do not take the individual square roots of that, because you cannot do that mathematically. So this is the square root of 130, and that is your radius. So you will need to square it. So this equals 130, not 100, the square root of 130. All right, let's do that again on the next one. So obviously I can start by putting in my x minus 4 squared plus y plus 10 squared, and I need to figure out what it's going to equal. So using the radius formula, or the distance from the center to any point, which is why it's the radius, is going to be 4 minus 10 squared plus negative 10 plus 15 minus a negative squared, okay? And cleaning that up is going to be negative 6 squared and 5 squared. Cleaning that up is 36 plus 25. You absolutely cannot take the square root of them before adding it together. So if you add those together, you're going to end up with the square root of 61. But I don't want the radius, I want radius squared. So this will equal 61. All right, and to wrap up our notes here with the endpoints of a diameter, you're going to want to find the middle. Once you find the middle, then you're going to want to find the length from the radius, or you can do the distance formula between the endpoints of the diameter and then take half of that and square it, whichever you prefer. But if I find the midpoint, which actually serves as the center, I want to average my x's, which is 1 minus 5, or 1 plus a negative 5, divided by 2, and negative 16 plus 4 divided by 2. So that's going to be negative 4 over 2 and negative 12 over 2, which means negative 2, negative 6. So far I have my x plus 2 squared and y plus 6 squared. And you can make the choice now to do it exactly as we did in numbers 11 and 12, using the center and one of my endpoints. Or you can use the two endpoints to get the diameter, cut that in half, and then square it. It's entirely up to you. I'm going to use that endpoint and my center and do it exactly as I did in 11. So r would equal the square root of 1 minus the negative 2, so plus 2 squared, and negative 16 plus 6, because it's minus a negative as well. And this is going to be the square root of 3 squared plus negative 10 squared, which will be the square root of 109. And if I square it, it's 109. Okay, last one together. Okay, so I'm going to find midpoint. My midpoint, which is my center, is going to be 9 minus 17, because it's plus a negative. And then 1 plus 5, which is going to be negative 8 over 2, and 6 over 2, which means negative 4, positive 3. So I can already write x plus 4 squared plus y minus 3 squared equals, and now I'm going to use one of my ordered pairs and my center to find the length of my radius. 9 plus a 4, because it's minus a negative, 1 minus a 3 squared, is going to be 13 squared plus negative 2 squared, which is 169 plus 4, or 173, which when you square it is 173. That's why I like using an endpoint in the center, is because I don't have to worry about dividing by 2 for the diameter. All right, that should be enough for you. Please go back and watch any part that you need to again, but that should be enough for you to be able to do the homework and have great success on it. But bring all your questions to class when I see you tomorrow, Wednesday.